So now we're going to learn about defer, and defer is a keyword, golang spec. And this is the official source you should always go to when, to find out the truth. And so defer is a keyword. And you can see it there. And so what does defer do? So if I have func foo, and func println foo, and then I have bar, and let's put these kind of in order. And then I call foo, oops, I call bar, so this is just normal. Foo bar, right? If I defer foo, bar foo. So defer can be used when you open resources, so that right when you open them, you could defer the closing of that resource. And that allows you to keep close in your code, opening and closing resources, so you can ensure, okay, when I opened this, it got closed. And it also allows you, like maybe you don't know where a function's going to exit, but whenever a function exits, defer is the last thing that runs. So right down here, defer would be the last thing that ran. And I think we might be able to see this in debugging. So if like I added a debug to like maybe right here, and then hit debug, and doesn't give me any more. So here's my call stack. I'm in main. Let's just like step in main, and then I'm in main bar. Step over. I'm back in main. I thought somewhere in here I'd see defer run. So now, I came to foo because of defer. Step out of. I thought defer was somewhere mentioned there, but I'm not seeing it. Anyhow, that's what defer does. Do you want to see an example of maybe where you might use that? So godoc.org and package OS, and we can look at the index here. And so in package OS we have file, and we have file open. And so it takes a name and gives us a pointer to a file. And notice these receivers here, right? So the type it gives us is a pointer to a file and an error. And then we have all these methods here attached to type file. So we could read, we could write, we could do all this stuff. But one of them's close. So if we're to open a file, we would then need to close that file. And so that's where we'd use defer. And so There's also a package buff.io, buff.io, and that gives us a new reader. And so we could open a file and then we could read over it. So, or we could write to a file. Write string. Create a new file. So do you guys want to try creating a file thing? Yes? Anybody? Sure? Game for anything? Feeling like it's late and you're tired? Go for it. So let's, not a lot of enthusiasm at this hour. .26 file. I'm not going to be able to code this perfectly because it's been a year. And so create a file. Gives us a pointer to a file and an error. So f error := and this is from OS, create file, create, and we have to give it a name and data.txt. If error is not equal to nil, meaning there is an error, we could panic and do the error. So we just close. Now we're going to save that. We brought in package OS. And now that we have a file, we can do something with our file. Write string, read. I'm just looking at these. So we probably want to defer close our file. So we have a file, defer close, f.close. Okay, so we'll f.close our file. And do I have that? It should be capital. There we go. So that's where we created a file to open, and then when this function main exits, we want it to be closed. All right, so defer close. And we got read, seek, set, write deadline, truncate, write, slice of bytes, write at slice of bytes, int, error, write string. Write string is like write, but writes the contents of string S rather than a slice of bytes. That sounds pretty good. So write string. So we could do for I ::= 0, I less than or equal to 100, and I plus plus. We can do f write string. And now we need some string here. So how can we randomly generate a string or randomly generate something to write? Or we could just do it this way. I will not talk in class. And we could also add in %d. And here we could do func.sprintf so that I'll put I there, so that it's string printing. And I guess we'll add the number to the end, %d, and save it. So does that make sense? So it's going to write that to our file. And go back and look at the index. Let's see if that works. We could also quickly take a look at, there's open, there's make. Let's see what happens. CD up a level, and we're in 0.26. Go run main. And so now it created this file, data.txt. And I forgot to add my new line. So new line. And let's get rid of data.txt. And run it again. So here is my punishment for talking in class. My homework's done. Super easy, right? That's kind of cool, isn't it? And then created a file. And then if I wanted to open that file, I've got func open. So I could, that file's now is actually, well, we created the file here. So let's copy this. So we're going to do current working directory, CD up a level, copy recursively and view, and we want to copy 0.26, and we're going to copy to 0.27 open file. So now we have 0.27 open file. And here, we aren't going to create, but we're going to do OS open. It needs a file name and gives us a pointer to a file and error. So it's pretty similar. We're opening data.txt, gives us a pointer to a file and an error. And now that we have a pointer to a file, what can we do? Well, we could write to it more. So if we write string to gum in class, right? So I could write another string to it. I opened it, and then if I read it, I get a number of. I could read dir name, seek. Well, now I could do this buff.io, okay? And so I added some lines. So let's just see if that adds those lines in. So it doesn't look like anything changed, but I'll not talk in class. Nothing changed. F write string. I will not chew gum in class. I opened this. Is there some way I have to save that data? So I opened the file. Maybe I need write at. I probably need to write at. Like find the end of the file. Because open file, I don't have that other stuff appended to the end. All right, so we're not going to do that with the file. But we will do this. We'll come over to buff.io, and we open the file. We get a pointer to a file. And we have new reader, gives us a pointer to reader. New scanner takes a reader. A file implements the read interface. And pointer to reader. type reader contains unfiltered or go doc. So we have type writer and type reader. Just kind of thinking this through. And a reader is anything with that. So there's the reader interface. And here we have a pointer to a reader. Wondering if that's the same reader interface. Okay, so here's IO reader. So new reader takes an IO reader. And we're going to learn about interfaces. So this is an introduction. An interface says, hey baby, you got this method, then you're my type. So any type that has this method is also implementing implicitly this interface. And so since file has this read method, anything that's of type file is also of type reader. And since buff.io new reader takes a reader, I could get buff.io new reader, pass in a file, it gives me a pointer to a reader, which then gives me access to all of these methods. Except I want a scanner. Same with a scanner. I could pass in a reader and I get a scanner, because then I could scan and then I could get text. So I'm going to do buff.io new scanner. So, and that's going to give me a scanner. Buff.io new scanner. And it takes a reader, which will be the file. And then when it scans, scan advances the scanner to the, so buffer is like an area in memory. Like you have your print buffer, your spooler, what the hell is it called? I can't think of it. Print spool, buffer spool, what's it called on your printer? Print buffer, right? It's like your computer will take all the data that it needs to send to the printer and put it in the print buffer. So it's sitting there waiting in memory. As the printer needs it, it can pull it. So buffer is a holding place in memory. So buff.io is input and output, a package to help you with doing input and output and putting stuff in memory to hold it. So, and scanner is going to scan through stuff, right? So here I've got a new scanner. And when I have a new scanner, I could scan. And scan returns a bool. And so scan advances the scanner to the next token, which will then be available through the bytes or text method. It returns false when the scan stops, either by reaching the end of the input or an error. After scan returns false, the error method will return any error that occurred during scanning, except that if it is end of file, error will return nil, right? So it's going to return false when the scan stops, right? So I'm going to do for s scan, and while we're getting true, we're going to get a line. They'll give us one line, give us the next line, and then advances to the next token. So the token is I'm just looking to see if it says anything about end of line. I think the token is like the end of the line, the new line character. And I'm wondering if there's a way to say what it is. Example lines. New scanner, scanner scan, print the text, if error, scanner.error, error. So there's the error statement. So then we would do s.text, and it would give us a text, and we want to print that to standard out. And then we'll do if error colon equal s error error not equal to nil, and we could just do panic error. We'll copy that one. Let's see what happens. 27 open file. So it got it all and printed it out to standard out. So now you could grab a file, you could open it, you could get data out of it, you could work with it. You could do like a word counter. And I deferred that close. So let's play with this a little bit more maybe in the next video because it's kind of fun.